A particulate air filter is a device composed of fibrous materials which remove solid particulates such as dust, pollen, mold, and bacteria from the air. A chemical air filter consists of an absorbent or catalyst for the removal of airborne molecular contaminants such as volatile organic compounds or ozone. Air filters are used in applications where air quality is important, notably in building ventilation systems and in engines. Some buildings, as well as aircraft and other man-made environments, use foam, pleated paper, or spun fiberglass filter elements. Another method, air ionisers, use fibers or elements with a static electric charge, which attract dust particles. The air intakes of internal combustion engines and compressors tend to use either paper, foam, or cotton filters. Oil bath filters have fallen out of favor. The technology of air intake filters of gas turbines has improved significantly in recent years, due to improvements in the aerodynamics and fluid dynamics of the air compressor part of the gas turbines. Automotive cabin air filters. The cabin air filter is typically a pleated paper filter that is placed in the outside air intake for the vehicle's passenger compartment. Some of these filters are rectangular and similar in shape to the combustion air filter. Others are uniquely shaped to fit the available space of particular vehicles' outside air intakes. Being a relatively recent addition to automobile equipment, this filter is often overlooked, and can greatly reduce the effectiveness of the vehicle's air conditioning and heating performance. Clogged or dirty cabin air filters can significantly reduce airflow from the cabin vents, as well as introduce allergens into the cabin airstream. The poor performance of these filters is obscured by manufacturers by not using the MERV rating system. Some people mistakenly believe that some of these are HEPA filters. Internal combustion engine air filters. The combustion air filter prevents abrasive particulate matter from entering the engine's cylinders, where it would cause mechanical wear and oil contamination. Most fuel-injected vehicles use a pleated paper filter element in the form of a flat panel. This filter is usually placed inside a plastic box connected to the throttle body with ductwork. Older vehicles that use carburetors or throttle body fuel injection typically use a cylindrical air filter, usually a few inches high and between 6 inches and 16 inches in diameter. This is positioned above the carburetor or throttle body, usually in a metal or plastic container which may incorporate ducting to provide cool and/or warm inlet air, and secured with a metal or plastic lid. The overall unit is called the air cleaner. Long life filtration system. In 2003 Ford Motor Company introduced the Visteon long life filtration system to the Ford Focus. This system has a foam filter placed in the bumper of the car and is stated to have a 150,000-mile service interval. According to a technical paper published by Society of Automotive Engineers, this design offers higher and more stable filtration efficiency than conventional air filters. Paper. Pleated paper filter elements are the nearly exclusive choice for automobile engine air cleaners, because they are efficient, easy to service, and cost-effective. The paper term is somewhat misleading, as the filter media are considerably different from papers used for writing or packaging, etc. There is a persistent belief amongst tuners, fomented by advertising for aftermarket non-paper replacement filters, that paper filters flow poorly and thus restrict engine performance. In fact, as long as a pleated paper filter is sized appropriately for the airflow volumes encountered in a particular application, such filters present only trivial restriction to flow until the filter has become significantly clogged with dirt. Construction equipment engines also use this. Foam. Oil-wetted polyurethane foam elements are used in some aftermarket replacement automobile air filters. Foam was in the past widely used in air cleaners on small engines on lawnmowers and other power equipment, but automotive-type paper filter elements have largely supplanted oil-wetted foam in these applications. Depending on the grade and thickness of foam employed, an oil-wetted foam filter element can offer minimal airflow restriction or very high dirt capacity, the latter property making foam filters a popular choice in off-road rallying and other motorsport applications where high levels of dust will be encountered. Cotton. Oiled cotton gauze is employed in a growing number of aftermarket automotive air filters marketed as high-performance items. In the past, cotton gauze saw limited use in original equipment automotive air filters. However, since the introduction of the Abarth SS versions, the Fiat subsidiary supplies cotton gauze air filters as OE filters. Oil bath. An oil bath air cleaner consists of a sump containing a pool of oil, and an insert which is filled with fiber, mesh, foam, or another coarse filter media. When the cleaner is assembled, the media containing body of the insert sits a short distance above the surface of the oil pool. The rim of the insert overlaps the rim of the sump. This arrangement forms a labyrinthine path through which the air must travel in a series of U-turns, up through the gap between the rims of the insert and the sump, down through the gap between the outer wall of the insert and the inner wall of the sump, and up through the filter media in the body of the insert. This U-turn takes the air at high velocity across the surface of the oil pool. Larger and heavier dust and dirt particles in the air cannot make the turn due to their inertia, so they fall into the oil and settle to the bottom of the base bowl. Lighter and smaller particles are trapped by the filtration media in the insert, which is wetted by oil droplets aspirated thereinto by normal airflow. Oil bath air cleaners were very widely used in automotive and small engine applications until the widespread industry adoption of the paper filter in the early 1960s. Such cleaners are still used in off-road equipment where very high levels of dust are encountered, for oil bath air cleaners can sequester a great deal of dirt relative to their overall size without loss of filtration efficiency or airflow. However, the liquid oil makes cleaning and servicing such air cleaners messy and inconvenient. They must be relatively large to avoid excessive restriction at high airflow rates, and they tend to increase exhaust emissions of unburned hydrocarbons due to oil aspiration when used on spark ignition engines. Water bath. In the early 20th century, water bath air cleaners were used in some applications. They worked on roughly the same principles as oil bath air cleaners. For example, the original Fordson tractor had a water bath air cleaner. By the 1940s, oil bath designs had displaced water bath designs because of better filtering performance. Filter classes. European normalization standards recognize the following filter classes, see also, air purifier, clean air delivery rate, cyclonic separation, HEPA, impingement filter, nose filter, oil filter, respirator. References, dmvclinic.com. The cabin air filter ABC performance and benefits of zero-maintenance air induction systems. Society of Automotive Engineers. Site Xerox, 10.1.1.122.3342 Filter Selection and Performance. Filtration Engineering Limited. Retrieved April 15, 2012. External links. Comparative filtration efficacy and airflow tests for different types of automotive air filter elements. A detailed report concerning air pollution in India and the technologies being employed to help. Engineered Systems Magazine. Filter Selection, a Standard Procedure MERV Designations, ASHRAE. Filter Manufacturers Council Bulletin on Cleaning Heavy-Duty Air Filter Elements, Cross-Reference for Automotive Air Filters.